Okay, so we didn't get to record how to find the height, but we can record how to find the time. So we're going to try to find the t. Everyone write down t question mark. Velocity is 15.0. It's the same as the previous problem. Acceleration is negative 9.8, same as the previous problem. And we're going to borrow our answer from what was it? From Jesus. 11.48 is our final answer. Now, when we imagine how fast the rocket's moving at maximum height, v sub f is 0, because that rocket starts to come back down. Here's the equation we're going to use. Velocity final equals velocity initial plus gravity times t. This is a formula that will be always used to find time. You don't have to worry about the other formulas. This is why you're taking notes, so you can actually use this formula on your test. We're trying to find t, so we'll subtract both sides by v sub I. The result is v sub I, v sub f minus v sub I equals gravity times time. Next month we're going to be using temperature. So it'll be very annoying how to tell time from temperature. We'll make little details that help us distinguish between time and temperature. For now, t is always time. Solve for t, so divide both sides by g. And what's left over will be v sub f minus v sub I divided by g. So algebra, again, just plug in. Our v sub f is 0. Our v sub I is 15. Our gravity is negative 9.8. Looks very similar to our previous problem, but no exponents. So Crystal, grab a calculator, put in negative 15 divided by negative 9.8, and you'll have time, of course. Okay, we've got some Crystal, what'd you get? 1.53. That's how many seconds it takes for the rocket to reach maximum height. Now, with this information, we can calculate the final velocity. And that means there's a new v sub f. Because when that rocket returns to ground, it's going to be going really fast. And a lot of you saw that because it damaged the cone, or it damaged the egg, or there was a very loud thud of your rocket. So it's going to be a new v sub f. And if the rocket takes 1.53 seconds to go up, it should take 1.53 seconds to come back down if we ignore drag. Now, a lot of physics problems, before you become an engineer, you pretend friction doesn't exist and drag doesn't exist, or air resistance. Otherwise, it's too difficult for beginning physics students to learn the physics problems. So we're just going to pretend the 1.53 seconds going up and the 1.53 seconds down is the new t. So we have a new f, a new v sub f, and we have a new time. And I wrote those in red. And the equation to use for finding the new velocity is the same one we used earlier. But now we have to find v sub f. We're not trying to find how high it goes. We want to find how fast it comes down and crashes. So v sub f is unknown, but v sub I is known, a is known. Let me draw this a little better. And time is known. But we only know time because Crystal helped us find it in problem B. Good morning. So you're going to sit across from Elijah. Yeah. Let's have a student do this calculation. Yale, grab a calculator, put 15 plus negative 9.8 times 3.06. 15 plus negative 9.8 times 3.06. You should have a 14.99. I like how he rounded at the hundredths. A lot of you are asking, when do I stop writing down numbers in the calculator? It's when your hundredths is rounded up or stays the same.